Hello, I am Blaze, and now for something completely different. Yep, I'm doing one of these more techie videos again. As you may be aware, I've recently got myself back into retro gaming a bit. I do actually have a retro gaming PC I want to make a video on at some point, but that's for another time. For today, I'm talking about my Super Nintendo. I posted a teaser image on my Twitter account. Give me a follow on there, by the way. I announce video posts and live streams on there, which hinted at this video, but nobody really noticed that I was running a Japanese Super Famicom cart on my Super Nintendo, which is very much a UK PAL console. You can thank the SuperCIC region mod for that, and that brings us to the actual topic of this video. Let me take you on a journey that I like to call "Some Idiot Completely Overestimates Their Soldering Abilities but Still Somehow Manages to Not Ruin Everything." It's a working title. First, a quick demonstration to show that my Super Nintendo is indeed not capable of running imported games by default. No surprises there. Here's most of the stuff you'll need if you decide to do this for yourself, plus some other stuff you'll probably also want that I didn't have. The SuperCIC mod chip, developed as an open source design by some very clever people known by the handles Borty4938 and Ikari_1, is more or less the star of the show here. You're also going to need a game-bit screwdriver to open the console up, a soldering iron, ideally temperature controlled, solder of course, thin gauge wires, and a simple voltmeter with a continuity check so you can tell if things are connected or shorted out. Some flux paste also helps a lot. As for the extra stuff you may want that I didn't have, we'll get to that shortly. Before doing anything else, discharge the power supply capacitors. This is done simply by toggling the power switch when the console's unplugged. If there was power held within the capacitors, you'll see the power LED flash briefly. If you indeed do not want to end up sending a pulse of current through somewhere important and fry your console, then do not forget this step. After ensuring I wasn't going to immediately ruin everything, it was time to open the console. It's held closed with 6 game-bit security screws, and as long as you have an appropriate screwdriver, the opening process is pretty simple. I already checked my own, but there are multiple different hardware revisions for the SNES. The most notable being the one-chip version, which is one of the latest versions, and has superior picture quality output, but involves a slightly more difficult mod with a different SuperCIC mod board to work. If you have a one-chip console, it's probably best not to tinker with it too much due to its rarity. The one I have is an earlier 2-chip version. You'll need some Phillips head screwdrivers to remove the internal screws, as well to remove the RF shield plate and release the Super Nintendo's motherboard from its spot in the bottom of the console shell, so you can actually access the bottom for where the mod daughter board will go. I found that you can just leave the power circuitry shield plate and heatsink in place on the back of the board. You're not going to need to touch anything back there. The first part of the installation is quite simple. I just needed to align the mod board with the pins that protruded on the other side from the cartridge slot. This was just a case of matching up the pin numbers as marked on both the daughter board and on the SNES motherboard, and soldering where there were indeed soldering pads. While I was here, I went ahead and added some solder to the other pads I was going to use later that would go to where the original CIC chip was, the PPU pins, and the controller port. After that was another relatively simple operation, disabling the original region chip. This can be done either by removing it entirely, or by lifting a few specific pins. Just removing it entirely is by far the simpler option. I tried being fancy about this by using some flux and a piece of solder wick, but that didn't really work out for me, so instead I just connected all of the pins with a crap load of solder and levered the chip off at one side at a time, which worked out fine. And at this point I kinda started wishing I had a pair of some electronics tweezers. Having some actual electronics tweezers would have been far less cumbersome than trying to do this with a pair of pliers or a knife. After that came one of the trickier parts, which was running wires from the CIC mod daughter board to pads 10 and 8 of where the original chip was. Pad 10 was pretty easy since it was a relatively large pad at the corner, but pad 8 was much smaller. I really wish I had smaller wires for this, and on top of that I misinterpreted the continuity test between the pads because I hadn't realized or noticed that some of them were intentionally connected by either a capacitor or resistors. So that led to a lot of resoldering that I didn't need to do, and that led me to creating one of my own biggest problems on this project. You see, how printed circuit boards work is that there's a structural material, usually fiberglass, with the conductive copper material deposited on top. The issue with this is that if you apply too much heat for too long to specific pads or traces, the bond can fail, and that resides in pads or traces getting burned off. Which is exactly what happened to me while I was futzing around trying to fix a problem that apparently didn't exist. resulting in a solder pad not being there anymore. Well, shit. Fortunately, this wasn't the end of the world. There was actually a trace that ran underneath the chip to a pair of plated through holes, and I managed to connect the wire there after scraping off the original insulation silk screen and making the wire a bit thinner. So, a bit of panic moment there, but I managed to fix it just about. With that dealt with came the most difficult part of the mod. I needed to lift pin 30 of the SPPU2 chip and pin 24 of the SPPU1 chip, and run wires from those pins to the pads on the SuperCIC board. Those pins would actually be connected together with this mod, so if you do this, you can make things a little bit cleaner if you just run a wire between those pins, and then connecting that to one of the pads on the mod board. So to begin this delicate and extremely important operation where I needed to completely make sure I knew what the hell I was doing, I immediately began lifting pin 30 on the wrong chip. Yup. I do realize I probably shouldn't be allowed a soldering iron at this point. Fortunately, I did realize my mistake and then began work on lifting the actual correct pins after resoldering the pin I had lifted by mistake back to the pad where it should have been. But this didn't come without its own issues. Those pins were very close together and quite small, which made it extremely easy to accidentally short things together as I was resoldering SPPU1 pin 30, and that's exactly what happened, so I ended up having to spend a lot of time dragging solder away, reapplying flux, wicking away, and reflowing solder until things seemed largely as they were supposed to. Not wanting to lift the wrong pin again, I then spent a perhaps unnecessarily long time counting out exactly and precisely where pin 24 was, because after all of this I didn't want to lift the wrong pin again. It was a bit tricky, but I was just about able to lift the pin up with the tip of my knife and expose it for later. Unfortunately, all of this moving around of the board didn't play nice with the repairs I tried to make to pad 8 on the CIC, and the wire ended up getting ripped off along with the traces I'd exposed for soldering. God damn it. Fortunately, this still wasn't the end of the world, though at this point it probably should have been, and I instead followed where the plated through holes went and soldered the wire to the underside of the board, so crisis averted, yet again. And this time it actually stuck. After that return of a panic moment, I do one of the few things I do somewhat properly on this journey and apply Captain tape to protect the remaining PPU pins, and have more ready to act as some mechanical supports for the lifted and rather vulnerable pin for later. Captain tape is actually intended to be used for these electronics applications, thanks to Captain being stable over a wide temperature range. Do not use standard electrical tape for this kind of thing, it will degrade over time. That's a very common mistake. After this, I did the significantly easier task of lifting pin 30 on PPU2 right at the edge, and did the same motions of applying Captain tape and running another wire down to the mod board. After the stress of working on those tiny PPU pins was the much easier step of soldering wires to the controller input pins so that the mod chip could actually be given some input controls with the SNES controller to run either a forced PAL mode, a forced NTSC mode, or an auto detection mode based on the cartridge. This just needed 3 wires going between controller pins 10, 8, and 6, and the respectively numbered pads on the mod board. Simple, quick, and more or less painless. Try not to mind my inability to cut wires to consistent lengths too much. The final touch was just connecting that fancy little red-green combination LED to the front panel so the mod could visually indicate what mode the console was running in. I tried to disassemble the controller port assembly to remove the original red LED, but everything was soldered down pretty hard, so I just ended up removing the solder from the original LED, and then removing it from its slot with brute force and violence. Then I just soldered the LED cathode to the relevant spot on the controller input board, and I was good to go. Just plug things back in and test it to see my handiwork, right? Moment of truth. Have I completely killed my own system? Let's see. Well, crap. As you can imagine, I was a bit stressed out at this point, but I persevered, and it transpired that I managed to avoid doing some permanent damage. Remember when I said I ended up having to spend a lot of time dragging solder away, reapplying flux, wicking away, and reflowing solder until things seemed largely as they were supposed to? Yeah, things weren't as they should have been. So some close visual inspection and reflowing later, I cleared up the shorts, but not without destroying yet another solder pad, this time right underneath one of the PPU pins. Fortunately, again, it was relatively easy to fix, and the pad I ruined was actually very close to its own plated through hole. I think this might have been part of the reason why I ended up burning it so easily. It was a relatively short run of trace, so there was very little thermal mass, so it all heated up much more quickly compared to the other adjacent traces. So, another wire run later. I really wish I had some magnet wire here, because that would have been more appropriate for such a narrow run. And connection to a small PPU pin, I fixed that as well. I plugged the SNES in again, and this time it worked. My mod was successful.
MTSCJ game is working! Yes! Fuck yes! Oh, by the way, I was dumb. I forgot that you were supposed to either close that jumper right there or wire that top pad to SIC pin 7. I didn't do either of those, so this thing stopped working. Although, for some reason it worked at first, I don't know, but I'm fixing that now, don't worry.
So now you might ask, why I bother doing this? What's the benefit of being able to run imported games? Well, besides the fact that some games weren't released in Europe, this goes into technical aspects between regional power grids and video standard differences. Long story short is that NTSC games ran at 60Hz due to electrical systems and video standards in those countries running at 60Hz, and PAL systems ran at 50Hz for the same reasons. This was important because video game frame rate was also tied into those numbers as a result. Older games output a 240p video signal, which is sort of a weird implementation of the 480i video standard in NTSC regions. The basic difference between interlaced video scan and progressive video scan is that an interlaced video draws every other line on the screen, known as a field instead of a frame, in one interval, then the other set of frames on the next one. This produces some slight flicker, but is generally not especially perceptible to the human eye and brain. Progressive is the usual digital standard now and simply does every frame in its entirety from top to bottom. 240p video was represented on a 480i display by drawing just one set of lines, and the others were left blank on the next cycle. This is why old games on a CRT display had that scan line look. This also means that those games actually run at half the standard refresh rate. 30 frames per second for NTSC regions and 25 frames per second for PAL regions. So people over here in the PAL regions actually lost about 18% of the frames per second, or about 5 frames per second. This largely isn't a concern anymore, thankfully, since analog video standards are all obsolete now, and pretty much any display can handle at least 60 frames per second. But it does have some pretty major implications for older games. 1, lower frame rates are always objectively inferior anyway, but 2, games were often programmed to be frame rate dependent, and since a lot of games were developed in Japan and North America for NTSC 60Hz regions, what usually happened when games were released in PAL regions was that nothing was adapted as it should have been, and the game didn't just run at a reduced frame rate, they also outright ran in slow motion. If you've compared Sonic the Hedgehog between the NTSC and PAL releases, then that's one of the more obvious examples. And I have heard of later examples as well. Apparently the PAL release of the first Devil May Cry also ran much too slow. But I do have one here with me. F-Zero. Nintendo, to their credit, was mostly pretty good about reprogramming its games to compensate for the timing differences for SNES games, but a few earlier ones slipped through the cracks, namely F-Zero. They programmed the clock to try and hide it, but the game still runs noticeably slower, especially if you compare them side by side. So that's one big reason to have an NTSC-capable console. A lot of NTSC versions were the superior versions due to how they ran, hence the bit of uproar over the botched ROM choices in the recent PlayStation Classic console. Other games do actually run properly, like Super Metroid. Here's a comparison for the PAL release and the Japanese Super Famicom release. Speeds are pretty much as they should be, although the PAL release does still have the disadvantage of running at only 25 frames per second. Also, you might notice that even though the Super Famicom version was for Japan, the game is still in English. Funnily enough, there are some Super Famicom games like this which are either English friendly or are in some cases almost the exact same game that the Americas got, which I find pretty amusing. And it's also extremely convenient for collectors and retro enthusiasts. Another minor distinction is that NTSC uses the 480i standard, but PAL regions actually use another standard, 576i. Yes, PAL region analog televisions actually had a higher vertical resolution, but this leads to another issue in that most games were never really programmed to take advantage of it. So we'd end up with games that had black bars along the top and bottom, while NTSC games filled out the whole screen. It was rare that developers would actually take advantage of or care about any of these differences. And Funnily enough, the developer Rare actually did care because they were in fact a British studio, so Rare games are one of the few third-party titles to actually run as they should on both PAL consoles and NTSC consoles. Most other third-party developers never bothered reprogramming their games to actually account for the timing differences between these regions. So that is why having the ability to run NTSC releases over here is generally pretty helpful. Which leads to another question. Instead of all of this stress, bother, and damage with modding your own console, why didn't you just buy an NTSC console? Well, one, the console would need some special power conditioning. Since the power brick circuitry would be expecting a 110 volt 60Hz mains power instead of the UK's 240 volt 50Hz mains power. Secondly, this was also an interesting project that I could make a video out of. Third is that using this mod actually does let me force PAL games to run in NTSC mode. Whether or not this works is a bit hit or miss. Some games experience graphical errors. Star Fox is one example of graphical errors with the strange vertical bar of broken graphical access near the center of the screen. But it can also allow slower PAL games to run at more or less the intended speed. F-Zero in a forced NTSC mode runs pretty much how it should, minus the timer running much too fast now. Just make sure you don't run PAL games in NTSC mode if they've already been compensated for the speed difference. Super Mario World, Super Metroid, and Legend of Zelda: Link to the Past end up running much too fast when running in a forced NTSC mode. One other interesting thing to note is that auto-detection mode doesn't always work perfectly. Usually it does, but I did notice in my testing that the PAL release of A Link to the Past incorrectly runs in NTSC mode when the SuperCIC mod is in its auto-detection mode. This is pretty easily fixed by just forcing the mod into PAL mode at least. Number 4, the American Super Nintendo console is fucking ugly. And 5, I guess I just apparently enjoy torturing myself. Ha, fucking kill me. And that should be all for this video. I'll probably be doing some other things with the SNES in the future, like getting some Retro Bright on there to reverse the plastic yellowing, but for now I have quite a functional multi-region console. Admittedly, the mod isn't absolutely 100% perfect. The console seems to output a video signal at about 59.58 Hz rather than an even 60, so it'll run very marginally slower than a native NTSC console. But in terms of moment-to-moment gameplay, it should be pretty much imperceptible. Probably not really what you want if you're doing speedrunning though. Then again, if you're doing speedrunning, you probably wouldn't be allowed to use a modded console anyway because that would be considered cheating. Major shoutouts to my friend who actually sent this mod board to me as a Christmas present. If anybody here feels like doing their own mod project, I've got a link in the video description to the supplier for this mod, although there should be other sellers that are more local to you if you live outside of Europe. At this point, I just need to grow my games collection to actually take advantage of it. Thank you for watching this somewhat silly tech video project. All comments are appreciated, and I hope to see you around next time. If you enjoyed this content, then please consider checking out some of my other videos, and regardless, as always, take care.